Hi there and welcome to my weekly robot update. This is where I do a roundup of what's going on in the robot news around the world, so stay tuned. Hi guys, I'm Philip English from robophil.com and welcome to the Robot Weekly Update number 16. Today we're looking at cockroach. Get back! Salamander. And collapsing robots. Cockroach robots. Not nightmare fantasy, but science lab reality. Texas engineers attach a miniature computer wired into the nervous system of alive cockroaches for remote control and aim to gather video information in places such as broken sewers. They lurk in dark corners, feed off crumbs and obey the commands of humans. Years in the making and a contender for the most revolting creation to emerge from a laboratory, the robo-roach has arrived. Built by engineers in Texas, the robotic insect fuses a live cockroach with a miniature computer that is wired into the animal's nervous system. At the push of a button, a human operator can control the beast, or at least which way he scuttles. Liang, who led the research at Texas A&M University, said the controllable insects could carry tiny video cameras, microphones and other sensors. For those on board, it could gather information from places where humans would rather not be, such as collapsed buildings, broken sewers and the kitchens in students' house shares. Insects can do things a robot cannot. They can go into small places, sense the environment, and if there's movement from a predator, say, they can escape much better than a system designed by a human, Liang told The Guardian. He wanted to find ways to work with them. The US team made tiny backpacks for the cockroaches and stuck them on with paint. Normal glue did not attach to the insects' waxy backs. Each backpack contains a computer chip that could send signals down a pair of fine wires into nerves that control the legs on either side of the cockroach. With a rechargeable lithium battery to power the device, the total weight of the backpack was less than 3 grams. In a series of demonstrations, the scientists showed how they remotely controlled the direction of which the cockroach walked by stimulating nerves on either side of the body. When cockroaches walk, the 3 legs on each side move in time with each other, but the electrical pulses disrupt this, making the middle leg fall out of step with the others. The result is that the pulse on the left makes the cockroach turn left and vice versa. Blue Robot is an eerily lifelike robotic salamander. It's not particularly difficult to make a robot that looks like an animal. It's much harder to make a robot that behaves like an animal. At EPFL, a group led by Professor Jan Itzbert, has been working on swimming robots for over a decade, using the salamander as a model, and Blue Robot looks the most accurate and eerily lifelike yet. Alright, so the whole talking thing is maybe not typical behaviour for salamanders, but we'll let it slide. The key to Blue Robot's lifelike motion is its design, which was based on the 3D X-ray moves of a real salamander walking and swimming. Tracking up to 64 points on the animal's skeleton, they were able to record 3-dimensional movements of bones in great detail. Using optimization of all the recorded postures for 3 gaits, they deduced the numbers and positions of active and passive joints needed for the robot to reproduce the animal's movements in reasonable accuracy in 3 dimensions. By design, Blue Robot provides torque control for all the active joints, which enables us to apply our neural network models of the spinal cord neural circuits, called central pattern generators, of the salamander, and to activate virtual muscles to replicate the recorded animal movements along with the realistic viscoelastic properties. This is particularly important in order to get a fundamental understanding of vertebrate motor control. In other words, the joints and muscles of a robotic salamander respond in just the same way the joints and muscles of a real salamander do. This means that applying neural patterns that real salamanders use for walking to the robot salamander will or should at least cause the robot to walk in the same way, and it seems to work rather well. Blue Robot may not be the fastest of walkers, but its low centre of gravity makes it exceptionally stable. And it's also multimodal. It can walk on land, swim underwater and transition seamlessly between the two. This makes it ideal for obligatory search and rescue applications, although the aquatic operations, the robot needs to wear a waterproof swimsuit. A robot that collapses under pressure, but in a good way. If NASA plans to send robots to other planets, it's going to need some new designs. Ones that are easy to land, easy to move around, and easy to fix. This means they probably won't look like the biped T-1000 chasing the one hope for mankind. These probably won't even look like the four-legged galloping critters Boston Dynamic is building. Nope, these robots will look like a hexagonal tent stripped of its fabric. At the NASA's Innovative Advanced Concepts, that's NIAC program, engineers are developing just such a machine. They call it the Super Ballbot, a robot made of metallic rods and cables that can extend and retract on command. It looks a little bit like a tangled mess of toothpicks and dental floss, but in space the manipulated structure is ideal. It can expand and compress to absorb impact on landing, squeeze into tight spaces, and even move across the surface of a foreign planet in an odd crawling / tumbling motion. The robot's creators, Vitus Sunspiral and Adrian Igogino, will present the latest version of the Super Ball at the IEE International Conference on Robotics and Automation, ICRA 2015 in August. The pair first realised the potential of the squashable structure when they were playing with their 6-bar baby toys strung together with wire. Agogino threw it up in the air and Sunspiral noticed how well it absorbed impact when it landed. Sunspiral says, "Aha, it's a landing robot." That's it guys for your weekly World Robot News. I'm your host, Philip English. If you like this weekly report and want to see more of the latest robot news, reviews and robot tutorials, then please hit the subscribe button to keep up to date. I put further information about the robots in the weekly robot update in the links below, as well as extra web links for your review. If you have a robot product that you would like me to do a review for or do a tutorial for, then please ping me over a message in the comments section and I'll see what I can do. Thanks guys, looking forward to see you next time.